So we're now going to continue on with PON 8.8, solving equations with radicals. And the big idea for this section is to solve an equation of the form x to the m over n equals k, where m and n are integers. Take the nth power of both sides. Nth power of both sides. Or raise to the reciprocal power. So you could raise to the n over m and do both things at once. So you're raising it to the nth power and taking the mth root. So that's what you would want to do. But they say, be careful that you do not change the number of solutions to the equation in the process. So sometimes doing this, you might get solutions that are not legit, or you might, yeah, exactly. Or you might not get any solutions. Maybe you need some solutions. But more likely you'll get solutions, actually, basically always, you'd get some solutions that are not actually solutions. So make sure to check your answers. Or actually, yeah, sometimes you might get only one solution when there should be two. So just make sure that you are checking your work when you're doing this. Okay, so this one says solve the equation 5 minus the sixth root of x equals 8 by following the steps in example 2. I'm not going to follow the steps. I'm going to do it on my own. But I should get negative sixth root of x is equal to 8 minus 5, which is 3. So the sixth root of x is equal to negative 3. Now here I want to be thinking already. Can the sixth root of some number be negative? The answer to that question is no, because even roots are always positive. So they will never be negative. So there's no solution to this equation. But if I do it algebraically and raise both sides to the sixth power, I get x equals negative 3 to the sixth power. So x equals, and now I am going to check this because I don't know what this number is. Oh, they don't give it to me, but whatever negative 3 to the sixth power is. However, this is some positive number. And if I go back here and think, oh, 5 minus some positive number equals 8? No. So this actually is not going to work if I plug it back in to check it. And so this actually has no solution. So anytime you raise something to a positive power, you want to be, or an even power rather, you want to be pretty careful to make sure you don't get some extraneous solutions. Whatever this solution is, negative 3 to the sixth power, is an extraneous solution. Okay, and that's leading up to this next thing, which is saying, well, what is an extraneous solution? So if a solution to a later equation does not check in the original equation, it is called an extraneous solution, and it is not a solution to the original equation. Okay? So you can write that, but I won't. Number 4, explain how you know the following equation has no solution without completing any work. Okay, so I've got 2 times the square root of something equals negative 4. Well, a square root can never be negative. It has a positive domain and range, so there's no way that I can make this negative. Coming down here, if I solve it, what will happen? Well, 2 square root x plus 5 equals negative 4. So the square root of x plus 5 would need to equal negative 2. So x plus 5 would need to equal negative 2 squared, which is 4. So x would need to equal negative 1. Okay, but if I plug negative 1 back in, I get 2 times the square root of negative 1 plus 5 equals negative 4. So 2 times the square root of 4 equals negative 4. So 2 times 2 equals negative 4. So 4 equals negative 4, and it does not. So this is an extraneous solution. Okay, so you got to be really careful to make sure that you don't make a mistake here. Okay, Here, if I solve this by subtracting 12, multiplying by negative 1, raising both sides to the 8th power, I will get negative 8th root 3x minus 1 equals 15 minus 12, which is 3. So the 8th root of 3x minus 1 should equal negative 3. So 3x minus 1 should equal negative 3 to the 8th power. So 3x minus 1 equals some large number. Oh, I do have a calculator here, so maybe I should find that on my calculator. I can do negative 3 in parentheses to the 8th power, and I get 6,561. So then 3x equals 6,562 if I add 1 to both sides. And dividing by 3, x should be 6,562 divided by 3, which is some number. So if I check my work, I plug this in here, I'd get 12 minus the 8th root of, so this solution times 3 is just 665.62 minus 1. Does that equal 15, I want to know? 12 minus the 8th root of 65.61 equals 15. That I already know is 3. Does 12 minus 3 equals 15? No, 9 does not equal 15. So this is an extraneous solution. Now I should know that at the very beginning because right here I've got an 8th root equaling a negative number, and an even root cannot equal a negative number, so I'm out of luck. Okay, so in general, make sure that you check your work. Check your solutions after you get them, or think about it ahead of time to say, will this even have a solution? And that takes care of PON 8.8.